Cable television is a system of delivering television programming to paying subscribers via radio frequency signals transmitted through coaxial cables or light pulses through fiber optic cables. This contrasts with broadcast television, in which the television signal is transmitted over the air by radio waves and received by a television antenna attached to the television. FM radio programming, high-speed internet, telephone service, and similar non-television services may also be provided through these cables. A cable channel is a television network available via cable television. When available through satellite television, including direct broadcast satellite providers such as DirecTV, Dish Network and Sky B, as well as via IPTV providers such as Verizon FiOS and DIT and AMP-TU versus referred to as a satellite channel. Alternative terms include non-broadcast channel, a programming service, the latter being mainly used in legal contexts. Examples of cable, satellite channels, cable networks available in many countries are HBO, MTV, Cartoon Network, Eurosport and CNN International. The abbreviation CATV is often used for cable television. It originally stood for Community Access Television, a community antenna television. From cable television's origins in 1948, in areas where over-the-air reception was limited by distance from transmitters or mountainous terrain, large community antennas were constructed, and cable was run from them to individual homes. The origins of cable broadcasting are even older, as radio programming was distributed by cable in some European cities as far back as 1924. Analog television was standard in the 20th century, but since then cable systems have been upgraded to digital cable operation. History of cable in the USA and Canada. Cable television has gone through a series of evolutions in the United States and Canada. From its founding, it primarily served small communities without access to a television station, or ones with an adverse location that prevented reception of outside signals even if they were not far away, such as being in a valley. Particularly in Canada, communities with their own signals were fertile cable markets, as viewers wanted to receive American signals. Early systems carried only a maximum of 7 channels, using 2, 4, 5 or 6, 7, 9, 11 and 13, as the equipment was unable to confine the signal discretely within the assigned channel bandwidth. As equipment improved, all 12 channels could be utilized, except where a local VHF television station broadcast. Local broadcast channels were not usable for signals deemed to be priority, but technology allowed low-priority signals to be placed on such channels by synchronizing the blanking intervals. Similarly, a local VHF station could not be carried on its broadcast channel, as the signals would arrive at the TV set slightly separated in time, causing ghosting. The bandwidth of the amplifiers also was limited, meaning frequencies over 250 MHz were difficult to transmit to distant portions of the coaxial network, and UHF channels could not be used at all. To expand beyond 12 channels, non-standard midband channels had to be used, located between the FM band and channel 7, or superband, beyond channel 13 up to about 300 MHz. These channels initially were only accessible using separate tuner boxes that sent the chosen channel into the TV set on channel 2, 3 or 4. Later, the cable operators began to carry FM radio stations, and encouraged subscribers to connect their FM stereo sets to cable. Before multi-channel television sound became common, pay TV channel sound was added to the FM cable lineups. About this time, operators expanded beyond the 12-channel dial to use the midband and superband. VHF channels adjacent to the high band 7 to 13 of North American television frequencies. Some operators, as in Cornwall, Ontario, used a dual distribution network with channels 2 to 13 on each of the two cables. During the 1980s, United States regulations, not unlike public, educational, and government access, created the beginning of cable-originated live television programming. This evolved into today's many cable-only broadcasts of diverse programming, including cable-only produced television movies and miniseries. Live local programs with local interests were rapidly created all over the United States in most major television markets in the early 1980s. Cable specialty channels, starting with channels oriented to show movies and large sporting or performance events, diversified further, and narrowcasting became common. By the late 1980s, cable-only signals outnumbered broadcast signals on cable systems. Some systems were going beyond 35 channels. By the mid-1980s in Canada, cable operators were allowed by the regulator to enter into distribution contracts with cable networks. Large cable companies used addressable descramblers to limit access to premium channels to paying customers. By the 1990s, tiers became common, with customers able to subscribe to different tiers to obtain different selections of additional channels above the basic selection. During the 1990s, the pressure to accommodate the growing array of offerings resulted in digital transmission that made more efficient use of the VHF signal capacity. Fiber optics was common to carry signals into areas near the home, where coax could carry higher frequencies over the short remaining distance. Although for a time in the 1980s and 1990s, television receivers and VCRs were equipped to receive the mid-band and superband channels, such cable-ready tuners are rarely used now, requiring a return to the set-top boxes used from the 1970s onward. The conversion to digital broadcasting has put all signals, broadcast and cable, into digital form, rendering analog cable television service mostly obsolete, functional in select markets. Analog television sets are still accommodated, but the tuners are mostly obsolete, oftentimes dependent entirely on the set-top box distribution. In order to receive cable television at a given location, cable distribution lines must be available on the local utility poles or underground utility lines. Coaxial cable brings the signal to the customer's building through a service drop, an overhead or underground cable. If the subscriber's building does not have a cable service drop, the cable company will install one. The standard cable used in the U.S. is RG6, which has a 75 ohm impedance and connects with a Type F connector. The cable company's portion of the wiring usually ends at a distribution box on the building exterior, and built-in cable wiring in the walls usually distributes the signal to jacks in different rooms to which televisions are connected. Multiple cables to different rooms are split off the incoming cable with a small device called a splitter. There are two standards for cable television: older analog cable, and newer digital cable, which can carry data signals used by digital television receivers such as HD TV equipment. All cable companies in the United States have switched to or are in the course of switching to digital cable television since it was first introduced in the late 1990s. Most cable companies require a set-top box to view the cable channels, even on newer televisions with digital cable QAM tuners, because most digital cable channels are now encrypted or scrambled to reduce cable service theft. A cable from the jack in the wall is attached to the input of the box, and an output cable from the box is attached to the television, usually the RF in a composite input on older TVs. Some unencrypted channels, usually traditional over-the-air broadcast networks, can be displayed without a receiver box. The cable company will provide set-top boxes based on the level of service a customer purchases, from basic set-top boxes with a standard definition picture connected through the standard coaxial connection on the TV, to high-definition wireless DVR receivers connected via HDMI component. Older analog television sets are cable-ready and can receive the old analog cable without a set-top box. To receive digital cable channels on an analog television set, even unencrypted ones, requires a different type of box, a digital television adapter supplied by the cable company. A new distribution method that takes advantage of the low-cost, high-quality DVB distribution to residential areas, uses TV gateways to convert the DVB-C2 stream to IP for distribution of TV over IP network in the home. Principle of operation. In the most common system, multiple television channels are distributed to subscriber residences through a coaxial cable, which comes from a trunk line supported on utility poles originating at the cable company's local distribution facility, called the head end. Many channels can be transmitted through one coaxial cable by a technique called frequency division multiplexing. At the head end, each television channel is translated to a different frequency. By giving each channel a different frequency slot on the cable, the separate television signals do not interfere. At the subscriber's residence, either the subscriber's television or a set-top box provided by the cable company translates the desired channel back to its original frequency, and it is displayed on screen. Due to widespread cable theft in earlier analog systems, the signals are encrypted on modern digital cable systems, and the set-top box must be activated by an activation code sent by the cable company before it will function, which is only sent after the subscriber signs up. There are also usually upstream channels on the cable to send data from the customer box to the cable head end. For advanced features such as requesting pay-per-view shows, cable internet access and cable telephone service, the downstream channels occupy a band of frequencies from approximately 50 MHz to 1 GHz, while the upstream channels occupy frequencies of 5 to 42 MHz. Subscribers pay with a monthly fee. Subscribers can choose from several levels of service, with premium packages including more channels but costing a higher rate. At the local head end, the feed signals from the individual television channels are received by dish antennas from communication satellites. Additional local channels, such as local broadcast television stations, educational channels from a local colleges, and community access channels devoted to local governments are usually included on the cable service. Commercial advertisements for local business are also inserted in the programming at the head end. Hybrid fiber coaxial modern cable systems are large, with a single network and head end often serving an entire metropolitan area. Most systems use hybrid fiber coaxial distribution. This means the trunk lines that carry the signal from the head end to local neighborhoods are optical fiber to provide greater bandwidth and also extra capacity for future expansion. At the head end, the radio frequency electrical signal carrying all the channels is modulated on a light beam and sent through the fiber. The fiber trunk line goes to several distribution hubs, from which multiple fibers fan out to carry the signal to boxes called optical nodes in local communities. At the optical node, The light beam from the fiber is translated back to an electrical signal and carried by coaxial cable distribution lines on utility poles, from which cables branch out to subscriber residences. Deployments by continent. Cable television is mostly available in North America, Europe, Australia and East Asia, and less so in South America and the Middle East. Cable television has had little success in Africa as it is not cost-effective to lay cables in sparsely populated areas. So-called wireless cable or microwave-based systems are used instead. Other cable-based services. Coaxial cables are capable of bidirectional carriage of signals as well as the transmission of large amounts of data. Cable television signals use only a portion of the bandwidth available over coaxial lines. This leaves plenty of space available for other digital services such as cable internet, cable telephony and wireless services. Using both unlicensed and licensed spectrum, broadband internet access is achieved over coaxial cable by using cable modems to convert the network data into a type of digital signal that can be transferred over coaxial cable. One problem with some cable systems is the older amplifiers placed along the cable routes are unidirectional. Thus, in order to allow for uploading of data, the customer would need to use an analog telephone modem to provide for the upstream connection. This limited the upstream speed to 31.2 K and prevented the always-on convenience broadband internet typically provides. Many large cable systems have upgraded or are upgrading their equipment to allow for bidirectional signals, thus allowing for greater upload speed and always-on convenience, though these upgrades are expensive. In North America, Australia and Europe, many cable operators have already introduced cable telephone service, which operates just like existing fixed-line operators. This service involves installing a special telephone interface at the customer's premises that converts the analog signals from the customer's in-home wiring into a digital signal, which is then sent on the local loop to the company's switching center, where it is connected to the public switched telephone network. The biggest obstacle to cable telephone service is the need for nearly 100% reliable service for emergency calls. One of the standards available for digital cable telephony, packetable, seems to be the most promising and able to work with the quality of service demands of traditional analog plain old telephone service. The biggest advantage to digital cable telephone service is similar to the advantage of digital cable, namely that data can be compressed, resulting in much less bandwidth used than a dedicated analog circuit switched service. Other advantages include better voice quality and integration to a voice-over Internet Protocol network, providing cheap or unlimited nationwide and international calling. In many cases, digital cable telephone service is separate from cable modem service being offered by many cable companies and does not rely on Internet Protocol traffic or the Internet. U.S. triple play. Beginning in 2004 in the United States, the traditional cable television providers and traditional telecommunication companies increasingly compete in providing voice, video and data services to residences. The combination of television, telephone and Internet access is commonly called triple play, regardless of whether CATV or telcos offer it. More recently, several U.S. cable operators have begun offering wireless services to the subscribers. Most notably was the September 2008 launch of Optimum Wi-Fi by Cablevision. This service is made available at no additional cost to Optimum broadband subscribers, and is available at over 14,000 locations across Long Island, New York, and parts of New Jersey and Connecticut. Cablevision has has reported a double-digit reduction in subscriber churn since launching Optimum Wi-Fi, even as Verizon has rolled out Fios, a competitive residential broadband service in the Cablevision footprint. Other Tier 1 cable operators, including Comcast, have announced trials of a similar service in sections of the northeastern United States.